All right. So, a lot of what I'm going to talk about in this video is stuff that we actually just covered in class. We're going to cover it some more, but I wanted to make sure that it was on a video so that those people that were watching the videos to prepare for the quizzes would have it. So, there's two more rules that we went over in class. One of them is a power to a power rule. So, if we have x to the third raised to the fourth power, that's the same as saying x to the third times x to the third times x to the third times x to the third. And we know with multiplication we just have to add the exponents, so all of them together is x to the 12th. Well, the rule says we don't even have to do all of that. Instead, all we have to do is go 3 times 4, so it's 3 times 4, and that's equal to x to the 12th. Now, one of the big mistakes here is that some people confuse this one with the multiplication rule, where in the multiplication rule we are adding the exponents, and in this one we are multiplying the exponents. So it's just something to be aware of. This applies even with negative exponents and such. The other one is anything to the 0 power equals 1. So, anything. I can say that the marker that's in my hand to the 0 power is equal to 1. My hair to the 0 power equals 1. The screen that you're looking at to the 0 power equals 1. So, the long and short of it is x to the 0 power equals 1. Xy, in parentheses, to the 0 power equals 1. So, anything. All right. So, at this point, we've shown you all of the different rules dealing with exponents. So, now when we look at problems that are big, huge problems, so we could look at this problem: 15 x to the fourth, y to the second, and z over 25 x times 2xy to the 0 squared. So this is a big problem, and if you look at it as an entire problem, this is kind of daunting. In other words, kind of scary. But if we take piece by piece and just clean it up using the rules that we have, this is not so bad. So the first thing I'm going to do is I'm going to take a look at this y to the 0 power. Well, y to the 0 power is going to be just a 1. And 1 times anything just makes it go away. So this is the same as just a 2x raised to the second power. Now when we have 2x squared, that's the same as saying 2 squared x squared, and that's the same as saying 4x squared. So I can take all of this and replace it with 4x squared. Okay, that starts cleaning it up quite a bit. Now we look at the bottom here, or the denominator, and we've got a 25 times a 4. Well, 25 times a 4 is just 100. And then x times x squared is just x to the third. So we just cleaned up the entire denominator into a 100x to the third. So now our problem looks like 15 x to the fourth y squared z over 100 x to the third. Well, now we just reduce the number. So let's see, 5 goes into both of these, 3 and 20. So 3 and 20. X to the fourth over x to the third. Let's see, 4 minus 3 is just a 1. And then there's no other y's or z's other than the ones up on top. So we just put them in and we leave them the way they are. That's how every one of these big problems is done. All you have to do is just do one piece, then do another, then do another. And you can even do some of them out of order depending on what they are, but you can do them in a different order and still end up with the same answer as long as you're using the rules. Okay? So when you're taking a look at large problems, try not to panic and just slowly break them down using the rules that we've taught you. All right, see you in class.